Hi, Adela. This is problem 35 or 37 from page 350. Hope this helps you. All right, so we have the function y equals x squared plus 3x all over x squared plus x minus 6. First thing you have to do is you have to simplify the function if you can. And you'll notice that in the numerator, I can factor that into x times x plus 3. And the denominator factors into x plus 3 times x minus 2. So what you end up with in this example is a common factor of x plus 3, and that's how I yield the x over x minus 2. So what does this mean? Because this, I think, might be where your question lies in. From the beginning, let's be clear that the domain of this function is all reals, but x cannot be -3 or 2. Okay? So from the beginning, x cannot be -3 or 2. Those cause me to divide by 0. So with that, shh. I know, I can't think. Okay, sorry, my family was talking. I'll only be about 2 more minutes, guys. All right, so you don't have to turn the TV down. It won't pick up. Just you guys talking. Do you want me to go in the other room?
No, you're fine.
Okay. All right, is x over x minus 2. All right, so what is happening at -3 or -2? A hole could be happening there, or an asymptote could be happening there. Those are the two things that can be happening. So let's kind of keep going in the steps of the problem, and it should make sense. All right, so step 2, we're going to find the y-intercepts. And really, you can deal with this function now. And I'm going to show you why it doesn't make a difference. If I input 0 for x, I get 0 over 0 minus 2, and that is 0. If you had done it in the original, you still would get 0 over -6. So either way, you get 0, 0, this point right here, as your y-intercept. It also is your x-intercept. And this is where you just go back to your simplified version. And if I let this equal 0 over 1, and I cross multiply, I get x is equal to 0, and that is my other x-intercept. Okay. If you went into the original and did it, you might be like, oh, well, here I would get x is equal to 0, and I would get x is equal to -3. But remember that -3 is not in the domain of the function. So -3 cannot be an x-intercept. Okay, moving on. You have a vertical asymptote at x equals 2 because that was not a common factor in the numerator and the denominator. Because x plus 3 over x plus 3 was a common factor in the numerator and denominator, that's why that yields you the whole. So the common factor gives you the whole. The one that is not common yields the vertical asymptote. So you only have a vertical asymptote at x is equal to 2. Okay. You have a horizontal asymptote, and I have a big fat error there, at y equals 1. Okay. And really, if you kind of understand what's going on so far, the only point that I really need to pick, I see that I've got a point right here. So since I have this point right here, and I don't have any points that are on the asymptote, I know that the branch, I didn't do that very well, did I? I know that the branch, sorry, this is harder to do at home on your laptop. I think you get the drift. The branch is going to go like this. However, when I put in -3 into a t-chart, you output -3/5. So at -3, 3/5, that is where you have your hole in the graph. So at -3, -3/5. Okay, so it's going to be right under here. That is where you have a hole in the graph. The next point that I might pick to figure out what's going on might be +3, because that's on the other side of the vertical asymptote. And when I put that into x over x minus 2, I yield 3 over 1. So that's going to be the 0.33. So that tells me that I have a branch up here. Okay, I know that wasn't very accurate. It's kind of hard to do this on the mouse at home. Hopefully this helps. Email me if you're stuck. Have a good one.